What did I tell you about the roof? It was a peaked roof in this building?
You lied to us.
I lied to you. Look here. That's flat. Did you know this building had a flat roof?
Yeah.
Huh? In the middle of this wing, the roof is flat. Now over here, there's a way you can crawl up there and climb out on the roof.
Can you go up there?
No, we can't go up there. But look how big that opening is there. It's what, about 3 feet by 6 feet ballpark? They designed that opening so that any piece of equipment in this attic could be lifted through that by a crane if it needs to be replaced. So you look at these things here, they all come apart. They're just pieces that are bolted together. So if this whole unit needs to be replaced, they don't have to go down the elevator or anything to take it out. Huh?
I think that's 2 different pieces. Yeah, everything's modular. Where you can be broke down into
Here's a variable speed motor drive, just like we have on the flow system, just like we have on the pressure system, just like we have on the voltage system, and just like we have on the electric speed system. So this is the same thing we're using in the lab.
That's our percent input.
Huh?
That's our percent input.
This is hertz.
Got it.
Okay, red team near the coffee.
More red team.
Over there, red team.
There's another red team.
Red team right there. This is red team. At least they got maintenance spelled right. That's the one I usually mess up. Talk to him. Talk to him. Are you going to do these?
That's awesome.
I'm going to do these. Have you seen that second commercial with the bank football field?
They were putting these bolts in. We were walking down the hall, and a piece of concrete fell.
Yep.
It went right through the ceiling tile. I was like, oh, that was close.
Yeah.
Peripheral voice.
They're real smart.
This unit that you see right here, this air handler, serves the card auditorium downstairs. We use this air handler just like the box that you saw in the classroom downstairs. We use this whole air handler that way. What we do is there's two things. We vary the amount of air that goes into the space based on the set point in the space, 72 degrees. If it drops below 72 degrees, just like that damper inside the VAV box, instead of closing a damper, we ramp down the fan motor. Ramp it down to a minimum hertz. If the temperature continues to drop, then we have heat, and we reheat the air going into space. The other thing, we were talking about this over there, you know, if it's below 55 degrees outside, we're not using cooling from the plant, we're using outside air. And that's what the duct you see coming in, that's coming in from outside. We take in outside air, just pass it through, and then we use the fan to blow it down into space. In a normal scenario, all you're doing is recirculating air. But whenever you're taking in outside air, you're pressurizing the space. So that's if you ever go in a building and you see the door standing open a little bit, they're taking in too much outside air. They don't have a negative pressure in the building. Well, to help create that negative pressure whenever we're taking in outside air, we relieve. So this is air coming back from the space. So instead of it going back in the air handler, we relieve it out into this space, and then they're actually around the corner. We've got open vents that just vent it out to the atmosphere. So this is called relief damping.
And the other air handlers have it, but this one's easier to see.
Yeah, this is the easiest one to see. All of them have got that though. All of them can relieve directly back out. That's what you see right here off this big air handler. That's what that is. That's called a relief duct. It's relieving when that air handler's in what they call a economizer cycle.
See that concrete block wall over there? The engineering, math, computer science building is legally 3 buildings. One of the buildings is what we call the west wing, from all over here around. Another building is the east wing, where most of the offices are. The third building is the Benwood Auditorium. When I say legally, that means for the fire marshal, you have to, if there's a fire in Benwood Auditorium, you don't have to get the people you don't have to get them outside. You can get them into this building, and that's an escape. This building is an escape if Benwood's on fire. A lot of picky details that you gotta know.
So there's no way to close off the breezeway in between the buildings on the second, or on the third and fourth floors, right? There's doors.
No, there's not. Not on the third
So
and fourth floor.
so that opening between the two, since there's a brick wall.
Yeah, that's enough for you.
That's enough. Okay.
If you ever look on the floor there's about a 2-inch strip on the third and fourth floor that is rubber or something like that.
There's strategic charges. If there's a fire, they blow the bridge.
The bridge.
Yellow over here. Yellow team over here. Who's here? What?
I'm not here.
That's
You're the only one here?
Yeah.
You're yellow team, okay.